Hello and welcome to my series of tutorials in which we are going to discuss about the engineering questions that are usually asked in interviews. So we have our first question, that is a statement, and we need to find out whether it is true or false. So the first statement is whether all the commercial liquid fuels are derived from natural petroleum or crude oil. So if I ask you, write down a few petroleum products or a few fuels that you know that is used commercially, what will be your answer? Your answer can be like kerosene oil, it can be petrol, it can be diesel or LPG. As we know that all these fuels are derived from the petroleum product, because the petrol is also a byproduct of the petroleum, or you can say the crude oil. Diesel is also extract from the crude oil, kerosene again a byproduct of crude oil, and LPG, that is again the liquefied petroleum gas, a petroleum product that is again derived from the crude oil. So the answer is true. Yes, all the commercial liquid fuels are derived from the natural petroleum. Next question is, a cycle consists of one constant pressure, one constant volume, and two isentropic processes. What is that cycle called? We have four options. Option 1 is Carnot cycle, second is Stirling cycle, third is Otto cycle, and fourth one is diesel cycle. So we need to find out a cycle that is having two constant process. One constant process will be the constant pressure and another constant process will be the constant volume, and two isentropic processes. So let's have a look over these cycles. And to identify these cycles, we need a PV diagram. Okay, so first we will check the PV diagram. So right here we have PV diagram for Carnot cycle. And from this diagram, it is evident that we don't have a constant pressure and a constant volume, because the volume is going to change from 4 to 1. And pressure is again going to change from 1 to 2. There is no constant pressure and no constant volume cycle. Let's have a look over the next chart, that is Stirling cycle. And under the Stirling cycle, we have two constant volume operations. As you can see, like from 3 to 4, we have a constant volume, and from 1 to 2, we again have a constant volume. But there is no constant pressure right here. So again, it is not the right answer. Let's have a look over the third one, that is Otto cycle. And under the Otto cycle, again we have two constant process, and those two constant process are from 4 to 1 and 2 to 3, and that is again the constant volume process. But we don't have a constant pressure in this diagram, so again it is not the right answer. Now the final one is diesel cycle. And under the diesel cycle, as we can see from this diagram, we have two constant process. One is from 4 to 1, that is a constant volume, and second is from 2 to 3, that is constant pressure. So yes, it is the right answer, the diesel cycle. The diesel cycle consists of one constant volume and one constant pressure. Again, it also have two isentropic processes, that is from 1 to 2 and from 3 to 4. So if you want to study this chart and want to know about why it is a constant pressure and a constant volume, so it is a chart that is specially meant for diesel operations. And under the diesel operation, from 1 to 2, the piston is going to compress the air inside the cylinder, and as soon as the air is going to be compressed inside the cylinder, the volume is going to decrease and the pressure will build up. W in represent the outside work that is applied to compress the air. Now over the point 2 and from the point 2 to point 3, heat is going to be applied at a constant pressure. Now why it is the constant pressure? Once your air is compressed inside the cylinder, fuel is going to inject in that hot air, and as soon as your fuel is going to inject in, it will build up heat in the form of fire. So as a fraction of time, your process will be at a constant pressure. It is not going to push your piston. Once your fuel is going to burn continuously, it will push the piston from 3 to 4 and will gives you W out, that is the external work, and after that from 4 to 1 the heat is going to be eliminated from the piston, that is represented with the Q out, and again it will have a constant pressure over here. So that is why diesel cycle is the correct answer.